What's the next word?
Soda.
Bicarb soda. So, this people often call this bicarb soda. It's actually sodium bicarbonate. Okay? Technically, sodium hydrogen carbonate, right? But sodium bicarbonate, yeah? It's baking soda, right? We have this in the kitchen at home, yeah?
Yeah.
So, we have that. And
Rocket ship.
what's this? Read the green writing on the white background. What's that there say?
Wait.
The V. No, with the V.
Here?
Yeah.
Vinegar.
Vinegar. Yep. So we've got sodium bicarbonate and vinegar. Okay.
Yeah.
Now they're going to have.
The rocket.
Yeah, and the rocket. You're right.
And the launch.
Correct. But the rocket's just the thing around the fuel.
Yeah.
That's fine. Just be careful. The sodium bicarbonate, guys, and the vinegar. It's going to have a chemical reaction. Okay. And it's going to make carbon dioxide.
Yeah.
That's a gas. That's CO2 gas.
Yeah.
Okay. And the thing is,
That's gas.
gases take up more space
Yeah.
than the liquid and the solid.
Yeah.
So that's going to build up pressure in the little launch tube here, and when that pressure is enough, the rocket's going to go
Into the sky.
into the sky.
And through the
Let's have a look, hey? All right, let's have a quick look at the chemical reaction that's going to be taking place shortly. We start with baking soda. Now, baking soda is sodium hydrogen carbonate, more commonly called sodium bicarbonate. So this is the formula for the baking soda that we start with. We're going to mix that with vinegar. And now vinegar is actually an acid. More about that a little bit later on. But we write it as CHOOH, CH3COOH. Now the reason we write this like that instead of, hey, there are 2 carbons and 4 H's and 2 oxygens. We could write it like this at the top, but that doesn't really tell us much about the molecule, how it's actually put together. So we tend to not. In fact, the COOH part here, the COOH, that tells us it's an acid straight away. Anytime you see COOH, you think acid. Now, so this is acetic acid. That's what vinegar is. It's actually called ethanoic acid, eth, because there are 2 carbons, right? Nothing says 2 carbons like the prefix eth. So ethanoic acid or acetic acid. So those are what we're going to combine. We're going to react them. They're called the reactants. And we're going to actually make 3 things. One thing we're going to make is called sodium acetate or sodium ethanoate. This is coming from the acetic acid, so it gives us the acetate, or we could call it from the ethanoic acid, so it gives us ethanoate. So sodium acetate or sodium ethanoate. That's one thing we're going to make. We're also going to make some water. We are also going to make some CO2. And this is, of course, the guy that's going to make the whole thing do its thing. So let's just throw in some states. The sodium bicarbonate, the baking soda, well, that was a solid. Now, the vinegar, that was a liquid. But wait, no, it wasn't actually a liquid. As an acid, it's an aqueous solution. All acids are aqueous solutions. In fact, that's part of the definition of an acid, that it will donate a proton in an aqueous solution, in a watery solution. That's what that aqueous means. It's not another state of matter. Okay, so when we're writing the states in our chemical equations, we're writing solid, liquid, gas, or aqueous, not a state of matter. It just means it's dissolved in water. It's in a watery solution. Now that's going to form sodium ethanoate or sodium acetate. That is actually also an aqueous solution. We're getting water formed. Now, water, of course, well, that's just a liquid. Water's not dissolved in water, is it? It's just water, so that's a liquid. But this is the key part here, that the CO2 is a gas. Now, gases take up a lot more space than solids and liquids. Okay, just as an example, if we talked about water, if we had 1 mil of water, oh, that should be, oh, that's a terrible M. Let's try that again. There we go, 1 mil of water as a liquid, and what we're going to do that is very, very quickly turn that into a gas. We're going to flash boil our 1 mil, and that gas actually occupies a volume of 2 liters. Now, the volume expansion, the change of volume, will be different for different substances, but for water, it's about 2,000 times greater. Okay, so 1 mil as a liquid becomes 2 entire liters as a gas. So gases really do take up more volume than solids and liquids. Now, this is because the particles have more energy, of course. They're moving around more. So if they're moving around more, they're taking up more space. So that CO2, that gas, is going to need to take up more space. So one way that it could take up more space and increase in volume is to smash the launch tube. But it doesn't need to do that because there was a hole at the top, so the gas can escape out the top. But wait, there was a rocket in the way. Well, I'll tell you what, let's push the rocket out of the way. So that's what's actually going on. The CO2 gas, the carbon dioxide gas that is going to be formed, is going to need to escape so that it can expand. So it pushes the rocket up out of its way and the rocket launches. Let's take a look. Right, Ken, you got the rocket?
Yep.
Excellent. What we've put in here is the liquid part of the fuel.
Yeah.
Yeah, the vinegar, didn't we?
Yeah.
And here's the solid part of the fuel, yes?
Yeah.
We've
and
got
then put that on it.
That's correct, we are. We've got a liquid-solid fuel combination, don't we?
And we have to run away from it so it doesn't land on us and hit our head.
Well, we are going to stand back so that just in case it's a bit windy, if the wind blows the rocket over just before it launches, we don't want it to launch at us, do we?
No.
No, that's why we're going to stand back, okay?
Yeah.
Okay, Ailish, hold.
And also it's a little bit windy, so
It is a bit
maybe
windy.
it might not happen. Kids, stand back. Yeah. Okay.
Okay, we're good?
Yeah.
We're just going to have to put this in here, and then we're going to mix them up a bit, okay?
Yeah. Okay.
Hang on.
Wait, with what?
My hand. One. Well,
That did not
that went
work.
up quickly. It said mix it twice. Give it 2 shakes. You know what we need to do, Ken? Let's start again.
It's
We like?
recording. Yeah.
Okay. Trial 1. It went pretty quickly,
Yeah.
didn't it, guys?
Yeah. So,
Instructions did say shake it twice.
yeah.
Yeah? Did we have time to shake it, Ken?
No.
There was no time, was there?
No. We didn't even check it once.
I know, right?
Yeah.
That's okay. Because, hey, what if something doesn't work? What do you do?
Try again.
Try again. That's right. That is exactly right. And that's what we're doing. Hey,
Yeah.
so we'll try it again. You got the lid? Yeah, cool. Put the lid on. Good job. Thanks. All right.
Stand back, Kian. In the hole. I'm in the hole.
Why? Because you saw what happened last time.
Yeah.
All right. Are we ready, guys?
Yeah.
Are we set?
Yes.
Am I going to shake it or am I just going to put it down?
Shake it.
Shake it? I tried shaking it last time. That didn't have time.
Shake it.
You can stop.
Look at that.
Yeah, you can stop recording now.
It's going.
Ken, what happened?
It got on my hand a little bit.
The vinegar?
Yeah.
Yeah, but that's okay because it's just acid. Hey.
Yeah.
Yeah, did you know it's acid?
No.
No, but it is. You got acid on your hand. What? Quick, wipe it on the grass. That's not the grass, it's your hand. No, you're fine. Hey, it is actually acid. Vinegar is actually acid, okay? Vinegar, guys,
Yeah?
is acetic acid, okay?
Okay.
Its actual name is ethanoic acid. It's a very weak acid, okay? Also, it's very dilute. So it's a dilute, weak acid, so it's not bad, hey?
No.
Not bad if we get it on. All right. Let's give this a go, yeah?
10.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm just going to go really quick this time, okay?
Yeah.
Yes, it's building up. That was a better launch. I'm not going to shake it at all. I'm just going to... Yeah, hold. There it goes. Cool.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.